Alright guys, so today we are going to be talking about your study guide for your final on Wednesday if you're cohort 1 or Thursday if you're cohort 2. So the first thing that you guys need to know are about rational and irrational numbers. So rational numbers can be written as the ratio, or in other words, that's just a fraction, of two integers. So if you have a fraction, it will be a rational number, or any number that can be represented as a fraction, it will be rational. You can also have the decimal form that can terminate, or in other words, that just means stop. So if you have like 0.25, since it stops, it terminates, so that is a rational number. Or if it repeats a pattern, then that is also a rational number. So if it's at a repeating decimal, it is technically classified as a rational number. Irrational numbers cannot be written as the ratio of two integers, so no fractions, and the decimal form cannot terminate or repeat a pattern. So in other words, an irrational number is going to be a non-perfect square root, or it's going to be a decimal that goes on and on forever. So that's this part down here. So it goes on and on forever, and it does not repeat. So let's go ahead and classify the given numbers for number 3 into the correct box. So when we have 3/7, notice that this is written as a fraction, and that is the definition of a rational number, is it can be expressed as a ratio. So 3/7 will be classified as a rational number. The square root of 18 is a non-perfect square root, so there's no number times itself that will give us 18, so this will be classified as irrational. -5 is an integer, so if it can be represented as a fraction, so you guys know that we can put these over 1, it will be a rational number. Square root of 36, this is a perfect square root because 6 times 6 gives us 36. So since this equals 6 and that's a whole number, this is a rational number. Pi, remember pi in math class we represent it as 3.14, but it is technically a decimal that goes on and on forever, that does not repeat. So pi is a irrational number. Square root of 25 over 4, notice that the square root of 25 is a perfect square root, so if we were to solve that, square root of 25 is 5, because 5 times 5 is 25. And then this would be over 4. So since 5 over 4 is a fraction, that is the definition of a rational number. So the square root of 25 over 4 is rational. And then that last one, -2.037812 and ... It does go on forever. And since it does not repeat, that is a irrational number. Okay, so if you guys know you can stop the video at any point if you need to catch up, but I'm just going to go ahead and go on. So number 4, the amount of time Pam spent studying for her test was 3.5 times the amount her friend spent studying. Her friend studied for 45 minutes. Pam says she spent 98 minutes studying. Explain why Pam's statement is not reasonable. So it's saying that her friend studied for 45 minutes and Pam spent studying for the test 3.5 times the amount that her friend was studying. So let's figure that out first to figure out how much time Pam was spent studying on this test, I guess. So we're going to take 45 times the 3.5, and you guys can use your calculator on your test. So if you were to take 45 times 3.5, you get 157.5. And this is talking about minutes. And in this statement, it says Pam says that she spent 98 minutes. Well, she didn't spend 98 minutes. She actually spent 157.5 minutes. So this says explain why Pam's statement is not reasonable. You can just say Pam spent 157.5 minutes studying, not 98 minutes. So as long as you show me some type of work as well as the statement, then you'll get your full credit. Alright, number 5, Tom is budgeting for a trip for 3 days. He spends $567.12 for his plane ticket, $231.98 for his hotel, $199 for his tour guide, $40 for his meals each day, I'm going to circle that word each, and $30 per day for spending money. He sets aside $1,106.78. Does he have enough money for the trip? Explain your answer. So we first just need to figure out how much is he or has he spent or is going to spend for this vacation for 3 days. So let's just start writing this down. So he spends $567.12 for his plane ticket, plus $231.98 for his hotel, plus $199 for his tour guide, plus $40 for his meal each day. So the reason why I circled each was because we have to include this 3 here since it's 3 days. So this is going to be 40 times 3. And then the next part is $30 per day for spending money. So again, 30 times the 3 days. And then we just need to figure out how much is that. So if I were to add all this up, if I were to take 567.12 plus 231.98 plus 199, all of that would give me $998.10. And then if I were to take 40 times 3, that's 120. 30 times 3, that's 90. So if I were to add all those together, that will give me a total of $1,208.10. So it's asking, does he have enough money for the trip if he sets aside $1,106.78? So if you think about it, no, he's not going to have enough money because it's going to be more than what he's expecting. So all that you have to put is he does not. He needs $1,208.10, and then you can even put that he is $101.32 short. So again, you guys just need to explain. If it says explain your answer, I better see some explanation with your work to back it up. Okay. Alright, moving on to the last one on this page. So number 6, Maggie has 50 raffle tickets to sell for her softball team. The first week she sells 8 tickets to her neighbor. The second week her mom sells 4 tickets at work. She sells 2 tickets a day, so 2 tickets a day for the third week. And if she sells a third of her raffle tickets to her uncle in the fourth week, how many tickets did her uncle buy? What do you need to know before figuring the number of tickets Maddie sold to her uncle? So, we can do this a couple different ways, but if she started out with 50 raffle tickets and the first week she sells 8, let's figure out how much she has after that. So, if we were to take 50 minus 8, so after the first week, she now has 42 tickets left. And then the second week, her mom sells 4 tickets at work. So she was at 42, and then her mom sold 4. So now after week 2, she now has 38 tickets. And then the next part, she sells 2 tickets a day. So if you think about it, there's 7 days in a week. So if she sells 2 tickets every day, we just need to figure out after the third week, how many tickets does she have left? Well, she started with 38, and she sold 2 tickets a day. So in other words, 2 times 7. This will give us 38 minus 14. So after week 3, she now only has 24 tickets. And they're saying for the 4th week, if she sells a third of her raffle tickets to her uncle, how many tickets did her uncle buy? So we just need to take a third of 24 to figure out how many tickets her uncle bought. So you could take 24 times a third, or in other words, that's just taking 24 divided by 3. So then 24 divided by 3 is 8. So her uncle bought 8 raffle tickets. Okay? And then you guys just want to make sure you answer every question that is being answered. So the 8 is talking about how many tickets did her uncle buy, but then it's also talking about what do you need to know before figuring the number of tickets Maggie sold to her uncle. So over here, you can just put Maggie sold 8 tickets to her uncle. And then for that second question, you need to know how many tickets she has left after 3 weeks. Because that's what we had to do first, right? We had to figure out, okay, after those 3 weeks, how many tickets does she have left, since she started with 50, but then she sold some throughout those weeks. So after the 3rd week, she had 24 left, and then we could figure out 1/3 of that to give us the 8. Okay? So that's the first page. Let's go ahead and move on to the second page. And again, pause the video if you guys need some extra time. So this backside is talking about our rules of exponents, which we have been working on for about a couple weeks now. So remember that when you are multiplying with exponents, if you have coefficients, you will multiply the coefficients like normal, and then you will add the exponents. Okay, so look at A here. So notice that these are not coefficients because these actually have the exponents attached to them. So these are our bases. So whenever you have bases, you want to keep the same base, and then you just add your exponents like normal. So 3 plus 5 will give you 8. Same thing for B. M is your base, so you want to make sure you keep M as your base, and then add your exponents. So 4 plus 2 will give you 6. And this last one, now we do have coefficients, because remember, coefficients are numbers attached to variables, so you can multiply 3 times 2 to give you 6, and then your bases are x and y, so you will still have x's and y's here, and then you just add your exponents. So for our x's, add your exponents of 2 plus 3, which will give you 5. And then add your y exponents, and please, 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 so many of you guys made this mistake. Don't forget that y has an imaginary 1 as an exponent. So when you go to add it, you need to add 1 plus 2, which will give you 3. All right. Now when you are dividing with exponents, you will simplify the coefficients and then subtract the exponents. So for A here, again, 10 is your base. All right, it's not a coefficient because there's no variables. So since 10 is your base, you want to keep your base of 10, and then you'll just subtract your exponents. So 7 minus 3 will give you 4. Same thing with B. You'll keep your base of C, and then just subtract your exponents. So 12 minus 7 is 5. And then your last one, you do have coefficients, so you can simplify those. So 24 divided by 8 is 3. And then you have bases of A and B, so then you can subtract your exponents on those bases. So 4 minus imaginary 1, so 4 minus 1 is 3. And then 7 minus 5 is 2. Alright, so this will be the end of part 1, so please go on to part 2 for your second video.